Airlines have returned to normal schedules after the worldwide chaos caused by the volcanic ash which spread from the eruption in Iceland. But the cost has been high, both in dollar terms and the inconvenience to travellers around the world. As a result of the crisis, a former CSIRO scientist has had renewed interest in a device he developed which can be attached to aircraft to detect volcanic ash in the atmosphere. He says it could have made a dramatic difference to the impact of the recent crisis. But after the CSIRO couldn't get a commercial backer to take it to the next step, he's now taken his idea overseas. Tracy Bowden reports.
As volcanic ash spewed into the atmosphere, airline flights were cancelled around the world and the travel plans of millions were thrown into disarray. One man was watching with particular interest.
I'm fairly certain that we could have had aircraft flying, in fact, all through the crisis.
Atmospheric scientist Fred Prater worked for the CSIRO for more than 20 years. During that time, he developed a volcanic ash detector which could be attached directly to aircraft.
The device measures infrared radiation, so that's heat, and we're able to detect silicate particles in the atmosphere, as opposed to ice or water vapour or water molecules, which are the normal constituents of meteorological clouds. So the device actually detects the ash hazard in the air.
I thought it had value both from the public good point of view, but also the potential for commercial development.
Back then, Graham Pearman was head of the CSIRO's Division of Atmospheric Research and could see the potential.
I thought, on balance, this was a good thing to invest in.
We field tested it in a number of times, actually. First with a very simple instrument way back in 1991 to 93 in Japan. And then we field tested it again in 2003. This time a more sophisticated imaging instrument. So we did all the tests and found that it all worked.
But the big challenge was finding the financial backing for the project.
At the time, it was this issue about, well, who will fund it and how will we go forward. Funding that kind of development was definitely not something that CSIRO would have done. We would have had partners from within the industry, and at the time we couldn't find them.
In this latest eruption, a British Airways jet carrying 230 passengers was nearly brought down.
The impact volcanic ash can have on aircraft was dramatically illustrated back in 1982, when a British Airways 747 lost power in all 4 engines while flying over Indonesia. It landed safely in Jakarta, but that event led to the setting up of 9 volcanic ash advisory centres around the world, one of them in Darwin.
So we didn't have any hot spots though, did we?
I haven't seen any as yet.
The Southeast Asian region is one of the most volcanically active regions in the world. For example, in Indonesia alone, there's about 130 active volcanoes that we keep an eye on.
It goes up to 35,000 feet.
Manager Rebecca Patrick says the centre's main source of information is satellite imagery.
As soon as we find out there's anything in the atmosphere that could be harmful, we issue volcanic ash advisories.
Fred Prater helped develop ash detection techniques used by the centre, but his aircraft device would have done much more.
We have satellites making measurements, we have models which are telling us where the ash is going, and we can draw rather conservative safety lines around the region that we think is contaminated. With the airborne detector, it's more of a real-time tactical solution. So with it being on the aircraft, the pilot can then see the hazard and take control.
The CSIRO's Graham Pearman may have supported the idea, but his successors were less enthusiastic. Eventually, Fred Prater left the organisation and he now lives and works in Norway.
I wasn't very happy about it, and I've moved on. I've found another job. I've continued developing it, and surprise, surprise, the kind of thing that we were expecting has happened.
But the CSIRO's Bruce Mapston says the organisation has no regrets about not taking the project further.
The technology was assessed over several years for its commercial prospects, and a decision was made at the time in 2007 based on the best available information that there just wasn't a commercial prospect there for that technology at that time.
After the staggering global impact of the volcanic ash spreading across Europe from Iceland, there's been renewed interest in Fred Prater's device.
It's quite amazing. A number of inquiries from avionics companies in the US. An airline, I probably shouldn't mention the name, has called me up and they want to meet me and talk about putting it on their aircraft. So lots of positive things.
And I was extremely disappointed when Fred did leave CSIRO, but not only CSIRO Australia. He was a good scientist, and he is a good scientist, and every time we lose one of these people overseas, I think that's a loss to the community.
Both Graham Pearman and Fred Prater believe that if his technology had been in use, it may have changed the impact of the volcanic eruption in Iceland.
One could debate, of course, if it had, whether we would have had a fleet of aircraft that would have been able to fly with their own capacity to determine whether in fact there was risk, rather than these overall blankets.
Aircraft with this on board could take off, fly to their destination. If there's a problem, they can deviate from their path, they can change altitude or veer to the left or to the right. So I'm pretty certain that we could have had aircraft flying.
Fred Prater has renewed optimism that his design will eventually be on the market, but is disappointed that it won't happen in the country where it all started.
Much prefer to have it Australian. I mean, I have an Australian passport, all my children are Australian, so yeah, I'd much prefer it to be Australian, but you know, that's the way it is.
A story that has some echoes. It's not the first time we've heard it. That report from Tracy Bowden.